Alright, so we're going to work through systems of inequalities today. Similar to systems of equations, but we are going to be dealing with inequalities rather than with equations. So first off, Sherry is trying to decide how many baseball and soccer games she wants to attend this spring. Travel time to the baseball games is 2 hours and soccer games is 1 hour. And she doesn't want to spend more than 15 hours traveling to the games. So in total, she would like to attend at least 8 games. And so what we're going to be doing is looking for the important information here. So we're talking about baseball and soccer games. Those are our two items that we're going to be talking about. Travel time is 2 hours to baseball games, and soccer games is 1 hour. And she doesn't want to spend, so no more than 15 hours. And in total, she wants to attend at least 8 games. So we're going to take this information and work with that. All right, so first off, we're going to start by defining the variables. So we're going to looking for, she's trying to decide how many baseball and soccer games. So we're going to be talking about the number of baseball games for her to attend and the number of soccer games that she wants to attend. And so I'm going to use B for baseball games and S for soccer games. Okay. And now I need to create two inequalities that are going to match what we're talking about here. And so it'll be very similar to the equations when we do the setup, other than you're going to have to decide which inequality symbol to use. So we have two main totals here that we're looking at. There's a 15 hours and 8 games. Okay, so we're looking for two things that are going to be 15 and 8. Okay, and so we're talking about the travel time here. We're talking about 15 hours. And so she says that it is 2 hours to a baseball game plus 1 hour to a soccer game. And she doesn't want to spend more than 15 hours. She does not want to spend more than 15 hours. So she's okay with spending 15 hours, and she's okay with spending anything less than that. So less than or equal to 15 hours, all right? And that would be the 2 hours for each baseball game plus the 1 hour for each soccer game. Now over here, we're dealing with the total of 8 games. She wants to go to at least 8 games. So the total number of baseball games plus soccer games has to be greater than or equal to 8. She's okay with going to 8, but she wants to go at least 8 or more than that. So we're going to use greater than or equal to 8 here. Okay. Now, to graph this, and that's how we're going to solve our inequalities, is we're going to graph them. We're going to graph them the same way that we graphed our systems of equations. So I'm going to treat B as if it's my x, and so I'm going to put it on the x-axis. So these are going to be the number of baseball games, and I'm going to do that 1, 2, 3, 4, 5, 6, 7. I'm going to go ahead and number those, and we'll just use 1 as our unit. And then up here we're going to have the number of soccer games. I'm going to treat that as my y. Okay. And so again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. All right. So now we've got our graph created, and we decided that we are going to, first off, put this in slope-intercept form. So that means we have to get the y, or in this case the s, by itself. So to get this by itself, I need to subtract the 2b. And so I'm left with s is less than or equal to negative 2b plus 15. Okay, so all I did was just move that 2b over. And so now remember, that means that my y-intercept is 15, which means our starting point is at 0, 15. And our slope is negative 2, or negative 2 over 1. Okay, so we're going to start with our y-intercept of 15. Okay, and I'm going to put a dot up there. It's at the very, very top of my graph, so it's kind of hard to see. And then I am going to go ahead and do my slope. So down 2 to the right 1, down 2 to the right 1, because remember this negative means I'm going to go down, and this positive means I'm going to the right. And so down 2, 1, and I'm going to continue that all the way down across my graph. Okay? Now, a couple things that you will learn, if you haven't already, about inequalities is that when there is an equal to symbol, it means that when we graph it with a solid line. So I'm going to go ahead and put that in there. Okay? And don't forget your arrows because it is a line. All right? And then when we graph it, we are going to shade less than. So everything less than this, I'm going to kind of shade in this purple color. Okay? And I don't want to do it real dark. It's kind of hard to do with a pen, but when you use your pencil, go kind of light so that you can still see what you're doing. Okay? All right, now I'm going to switch colors and we're going to work out this second inequality. So again, I want to get S by itself, so I'm going to subtract B and end up with S is greater than or equal to negative B plus 8. So my y-intercept in this case is B, which is 8. So 0, 8 is going to be my starting point, so I can go ahead and put my dot there. And then my slope is going to be negative 1. So negative 1 over 1, which means I'm going to be going down 1 and to the right 1 when I go to put my points. So down 1 to the right 1, and I'm going to continue that until I get to the bottom. And then again, I have an equal to. So anything on the line is part of the solution. So I'm going to use a solid line here. Keep my arrows, and I know it's a little bit difficult to see, but hopefully with the colors it helps. And then greater than. So I'm going to shade everything above that point. So what I'm going to do is take, and above that line, I'm going to shade everything in blue. Okay, and you can use just a regular pencil. Okay, and so what you will see is that the part where these two colors overlap, this section right here, okay, where these two colors overlap, there's purple here and there's blue here. This part right here is going to be where our solution is found. Okay, so if we look at the questions here at the bottom, the question is, suppose Sherry decides to attend 4 baseball games. So I'm going to go over here to where it says 4 baseball games, and I'm just going to kind of hold my pencil. It says, what is the range of soccer games she can attend? So I'm going to look up for the soccer games. And so that starts at 4 and continues up until 7. Okay, so see how from 4 to 7, from here to here, is all part of the solution. So she could attend 4 to 7 soccer games. That means she could attend 4, 5, 6, or 7. Okay, no half games because that's not a thing. Now she can do 4 and she can do 7, and she would still be within her limits of what she wants to do. Okay, so second question. Suppose that she decides to attend 9 soccer games. So now I'm going to go up to the soccer games. That's the Y up here to 9. And it's asking what is the range of baseball games that she can attend. So, well, I'm already at 0 here. I'm already in that range. So from 0 all the way over to 3 baseball games. Notice 3 is where I'm at. So from 0 to 3. So she could attend 0, 1, 2, or 3 games and still be in this solution set. So she could attend 0 to 3 baseball games at that point. Okay? And then the final question says, can she attend 6 baseball games and 4 soccer games and still meet her conditions? So I'm going to go to 6 baseball games, and then I'm going to put all myself up to 4 and put a little dot. And if you notice, I am just outside of that line. And so I'm in the blue here, and I'm not in the overlapping colors. And so because of that, the answer is no. she could not, okay, because that dot is outside of those lines, okay? So this is systems of inequalities. We're going to backtrack a little bit. I'm going to show you how to shade and how to do all of that with just a regular linear inequality, and then we're going to practice doing some more with systems of inequalities. We'll pause this video now, and then we'll start a new one that kind of backtracks a little bit. But this is big picture what we do with systems of inequalities.